This is Math Studies, section 5.1. A function is a relation in which each x has at most one y. And so sometimes we like the words inputs and outputs instead. So x's are the inputs and y's are the outputs. So that means anytime you put in a value for x, there's only one possible answer that you can get for y. The vertical line test is if you have a graph of a function and you draw a vertical line through it and it passes only one time, that is a function. It passes the test. Whereas if you have a graph and you're able to draw a vertical line through that graph and it hits it more than once, so here I can see it's actually hitting 3 times, that fails the test, so it is not a function. The same can be said for ordered pairs. Basically, if you have ordered pairs, x cannot repeat. And if you can imagine, the x-coordinate of this point would be the same as the x-coordinate of this point, and the same of the x-coordinate of this point, so x cannot repeat. If it did repeat, then the points would overlap when they graphed, and it would not be a function. The domain of a function is the realistic x values. Remember that x is the horizontal axis, goes side to side, and range is the realistic y values. And again, y is the vertical axis that goes up and down. So it might be helpful if you have trouble remembering that x is the side-to-side axis and y is the up and down axis. So if you're given a graph and you can see the values along the x-axis, those values are called the domain, and the values along the y-axis, those values are called the range. The first example says, tell whether the given relation is a function. Looking at this graph, I can even try my vertical line test. That passes the test, so yes, that is a function. Looking at the second one, I'll try my vertical line test and it hits the graph 2 times, so no, that is not a function. On the third graph, I'd actually have to check each individual point to make sure that no vertical line would hit 2 points, and I can see that they won't, so yes, that's a function. With the ordered pairs on D, E, and F, again, you could take the time to graph them. 1, 1 would be, I'm going to use this graph, 1, 1 would be here, 2, 3 would be here, 3, 4 would be here, 4, 2 would be here, and none of those points overlap. The simpler thing is looking at the simpler way is to look at the x coordinates. They're all different, so none of these points would overlap, so yes, that's a function. Here I have a 1, a 2, a 3, and a 4. Yes, that's a function. On the last, I have a 1 and a 1. I have a 3 and a 3, so if I were to graph those, I'd have 1, 1, 1, 3, those 2 blue points I just added, and my vertical line would hit 2 points, so that is not a function. Letter B says, give the domain and range for each function in example A. So I don't have to do all of the graphs, I just have to do the functions. So I'm going to do A and C and D and E. It'll be easier for me to type these, so I'm going to clear my ink. So for graph A, the domain of that function is -1 to +4, because the lowest that the graph goes is -1 and the highest it goes is +4. So There are different ways to write domain. In a more rigorous math class, we might see something that looks like 1 is less than or equal to x is less than or equal to 4. But I'm going to say you can go as simple as say domain is 1 to 4. You don't have to use the domain notation for any of your exercises. So I'm just going to focus on the simpler way. The range for this graph is the lowest y to the highest y. And I'm going to be careful on this one. The lowest y is here. Not down here, even though the scale goes to -1, the lowest point on the graph is at +1. And the highest point of the graph is at +4. So the range is 1 to 4. And as I'm saying that, I'm noticing right now that I messed up on my domain. The domain was -1 to 4. The range is +1 to 4. Letter B we're not going to do because B is not a function. Letter C, if it's not a continuous graph, you are required to list your domain and range singly. So I would have to list every single x coordinate. So I can see that's 0.5, 1, 1.5, 2.5, 3, 3.5, and 4. The range, following the same idea, would be 1, 1.5, 2, 3, and 3.5. Now notice there's more values in the domain than the range, and that's fine. Domain x's cannot repeat, that's why I have a domain value for every single point. Range values are allowed to repeat, so I had 2 1s and 2 3s. Keep going, and I'm going to do these ones quickly. The domain of letter D is 1, 2, 3, 4, and the range of letter D is also 1, 2, 3, 4. I'm going to save myself some time. D and E have the same domain and range. I can see 1, 2, 3, 4 for the domain again, and oh, I'm lying. Go me. I just looked at the domain. The domain is the same. But the range in this one is actually only 2. Every one of these y's is 2. Okay, so we have examples of how to tell if a graph is a function and how to find the domain and range of a function. So on the exercises, the first bunch are just yes or no, is it a function? And the second batch are find the domain and the range. Something that I don't like about the examples is that it doesn't talk about what to do when there's an arrow, so I'm going to do one of these also. And I'll do just the first one. I can see that the lowest x value is -1. Here's the x coordinate of this point. So my domain is going to be -1, 2, and this arrow actually indicates that it keeps going, so I'm going to say to infinity. So a sideways 8 is an infinity symbol. Doesn't look much better, but you get the idea. The range of this graph, the highest it goes is +3, the lowest it goes is to -infinity. Okay, so anytime you see a point, you can use the value of that point. Anytime you see an arrow, make sure you're using the infinity. Okay, good luck with the exercises.